Hello everyone. In this problem, a motorcycle has to move with a constant speed on an overbridge which is in the form of a circular arc of radius r and has a total length L. Suppose the motorcycle starts from the highest point. We have to find number 1. What can its maximum velocity be for which the contact with the road is not broken at the highest point? Number 2, if the motorcycle goes at a speed 1 by root 2 times the maximum found in part A, where will it lose the contact with the road? And 3, what maximum uniform speed can it maintain on the bridge if it does not lose contact anywhere on the bridge? So first of all, let's try to understand the scenario. So let's say this is an arc bridge. The radius of this bridge is r, and let's say this is angle theta, right? So let me draw it. So this is the radius r, the length of this arc is L, and this is the complete angle is, let's say, theta, right? When the particle is at the highest position, let's say at this position, so in this particular case the mv square by r centrifugal force will act upward direction and the mg force will act in the downward direction. Now this mv square by r should be less than equal to mg. If mv square by r is greater than the value of mg, then the motorcycle will lose the contact from the bridge, right? So mv square by r less than equal to mg, so m will cancel out, so this v will become less than equal to under root rg. So this is the maximum safe velocity by which the motorcycle can safely cross the bridge, right? So this is part A. Now for the part B, now in the second case, the velocity of the motorcycle is 1 by root 2 times the velocity found in the first case, and which was under root rg. So that means v2 is nothing but under root rg by 2. Now let's say at any time this motorcycle is at this point, and at particular this point the angle is alpha, mg will act in the downward direction. If this is alpha, then this angle is also alpha, so mg cos theta, or in this case cos alpha component, will act along the line OA, let's say, and also the centrifugal force will act in the upward direction along the OA, that is mv square by r. So if the contact is lost from the road, so that means mv square by r, in this particular case v is v2, should be greater than mg cos alpha. So m will cancel out, so cos alpha should be less than v2 square by r g. Now putting the value of v2 here, so cos alpha will become less than 1 by 2. So alpha will be 60 degree, that means pi by 3. Now for the third part, we have to find the maximum uniform speed can it maintain on the bridge if it does not lose contact anywhere on the bridge. From the previous problem, we understood that the chances of motorcycle to leave this bridge is somewhere here, or let's say in part from A to B. Let's say at that instant the angle is again alpha, so this is just similar to part B where mg force will act downward direction. This is angle alpha, and mv square by r is acting outward radially, and mg cos theta, or here in this case it is alpha, will act radially inward. So to safely move along A to B, mv square by r should be equal to mg cos alpha. M will cancel out, so v is under root rg cos alpha. Now the maximum value of alpha can be from A to B, which is theta by 2. Now gets the relation between alpha, L and r. So we know that theta is equal to arc upon radius. Alpha is the length will become half from A to B, so L by 2 into r. Now let's put the value of alpha here. V is equal to under root rg cos of L by 2r. So this is the safe velocity by which it can safely move along the bridge, and this is the solution of this problem.